Sometimes you need full control over the raw MCP protocol objects, not just the simplified results. We'll see how to bypass FastMCP's convenience wrappers and work directly with the underlying protocol responses, giving you access to every field, header, and metadata detail the server provides.
Async with client. Hash raw MCP methods return full protocol objects. Resources result equals await client. List resources MCP. Hash resources result MCP types. List resources result. Templates result equals await client. List resource templates MCP. Hash templates result MCP types. List resource templates result. Content result equals await client. Read resource MCP. Resource / example. Hash content result MCP types. Read resource result.
This demonstrates the protocol adapter pattern, providing direct access to the underlying MCP protocol while maintaining a higher level abstraction. The pattern exposes raw protocol methods alongside simplified client interfaces, giving developers fine-grained control when needed without sacrificing convenience. What makes this distinctive is its dual-layer design, where most operations use clean abstractions but can drop to protocol-level objects for advanced use cases. The approach works by implementing two parallel interfaces: simplified methods for common operations and raw MCP methods that return full protocol objects. This separation of concerns lets the framework handle routine tasks through clean abstractions while preserving access to the complete protocol when dealing with edge cases or server-specific features. The design follows the principle of progressive disclosure, where complexity is hidden until explicitly needed. This pattern matters because it solves the tension between simplicity and control in client libraries. Developers get 90% of functionality through straightforward methods, but can access the full protocol for debugging, interoperability, or server-specific features without switching libraries. It's particularly valuable when working with multiple MCP servers that may implement protocol extensions, or when building tools that need to inspect protocol metadata directly. The trade-off is a slightly larger API surface, but the benefit is avoiding the need for separate low-level and high-level client implementations. Let's break it down line by line.
Async with client.
Async context manager pattern ensures the MCP client connection is properly initialized and cleaned up after use, preventing resource leaks. The async with block handles connection lifecycle automatically.
Hash raw MCP methods return full protocol objects. Resources result equals await client. List resources MCP.
This calls the raw MCP protocol method, list resources MCP, returning the complete protocol response object. Raw MCP methods expose the full protocol interface, giving you direct access to all response fields and metadata without abstraction. Use this when you need low-level control over the MCP interaction.
Hash resources result MCP types. List resources result. Templates result equals await client. List resource templates MCP.
This fetches all available resource templates from the MCP server. The list resource templates MCP method returns a protocol object containing template metadata, enabling dynamic resource creation based on server-defined schemas.
Hash templates result MCP types. List resource templates result. Content result equals await client. Read resource MCP. Resource / example.
This fetches the actual content of a specific resource using its URI. The read resource MCP method returns a read resource result protocol object containing both metadata and the resource payload, enabling full programmatic access to the stored content.
Hash content result MCP types. Read resource result.
This comment documents the return type, MCP, types, read resource result, a strongly typed protocol object containing the resource content and metadata. Type hints like this enable IDE auto-completion and static type checking, preventing runtime errors from incorrect usage. Protocol duality pattern. The MCP raw methods return complete protocol objects, while their simplified counterparts return focused data, giving you both the full context and the distilled essence. The protocol objects contain metadata that often goes unused, but becomes invaluable when debugging cross-system interactions. Always check the meta field when unexpected behavior occurs in resource operations.
The response that reveals everything hides what matters most.